I'm here at the HiPEAC Conference in Barcelona with Margaret Martonosi, and she is professor at Princeton University. And we are talking about a very specific subject. We're talking about the world problems, and we're talking how computer architecture can play a role or should address these world problems. How are they connected?
I think there is a bridge, or else I
Otherwise, you wouldn't have
done it. But I definitely, there are easier talks to put together.
Sure.
That just focus on the technical side.
Yeah.
But I wanted to use this topic as a way to challenge myself,
Yeah.
make sure I was thinking through that bridge reasonably, and to see where else more might be possible.
Yeah.
And so there's parts of the bridging that I think are easier than others. So I think the issues of computer energy efficiency, and then leading out to climate issues for the planet and sustainability issues for the planet, I think that's very clear cut.
Yeah.
And we as architects have been working on energy efficiency for 20, 25, 30 years now. So that's not new to us. That's in our wheelhouse now.
Yeah.
But thinking about it in terms of its overall climate impact, I think that's important. And it's a place where helping, especially early career researchers, to think differently about their work can really lead to impact from our research community to the world.
You were talking about trustworthy computing systems, the trustworthy of computer systems. Can we trust computers actually to manage some of these big issues?
So I think when it comes to sort of trustworthy information, trustworthy computer systems, there's a whole lot of dimensions to that. And the example I gave in my talk was a deep dive into one aspect of computer reliability and computer security that is very closely related to architecture. But you can up-level, and there's broader issues of how information gets shared and communicated through social media, through different news sites, and how we learn about things worldwide. Those are other issues. When it comes to the connection to hardware, I think we do have opportunities in security and privacy beyond where we are right now. So, for example, differential privacy is a pretty well-known set of constructs for improving the privacy of data that gets used in broad systems. And we could do better on hardware support for differential privacy. For example, Apple and other companies are using differential privacy in what they do. But I think we as architects could think more in a more focused way about how we might support differential privacy by providing accelerators for certain mathematical constructs that are common in it, by providing different storage and data structure support, and so forth.
Will today's expansion of new architectures and new technologies, you see that as an opportunity or as a threat in what is going on?
Oh, I think it's an opportunity. So, if you look 25, 30 years ago, if you submitted papers to our research conferences that proposed changing the instruction set of the computer even a little bit, that was considered sort of off limits often, that reviewers were very skeptical of instruction set changes. Now instruction sets are much more, they're a part of a much more diverse and heterogeneous ecosystem, and so more changes are possible. And in a world where more changes are possible, I think there's more creativity that's possible. So what are secure storage structures that would help with privacy of data on different devices? I think those things are in scope in a way that they weren't 30 years ago.
HiPEAC Conference also brings together students and new opportunities, etc. You mentioned diversity in your talk. Diversity is important.
So I would challenge the folks who are admitting students into their groups to think about diversity at the point of how they admit graduate students or undergraduate students into their research groups. I think we could do a lot better there on a lot of different dimensions, and that's something that I hope I would see progress on. It's been coming, but it's been slow. And so in terms of individual students, what they can do is form networks amongst themselves. So I think HiPEAC is a wonderful opportunity for students to meet each other and for a student peer network, peer professional network to form very early in their careers, so that they're in conversation with each other across many universities, many institutions, both for the kind of technical and personal support that those relationships can help with early on, and also because your peers, when you're a grad student, become your professional colleagues for the next decades to come. And so sort of creating that peer network early can be helpful there.
From your perspective, and US perspective, how do you see developments here in Europe? Remarkably, in another speech, there were a lot of papers sent in from, for instance, from China and accepted over the last years. How do you see the European developments from computer architecture developments from a US perspective?
So I think, as I mentioned at the beginning of my talk, I've always looked with admiration and a wee bit of jealousy even at HiPEAC, because it forms this broad network, and it's a network that offers a lot of opportunities for collaboration and for tech transfer and so forth. So I think that's a wonderful thing, and I think European computing industry has some very rich developments in terms of European processor projects and so forth that are happening at scale, and the ability for European computer architecture researchers to start companies, to contribute to companies, and to work amongst themselves really effectively.